Who is a machine learning engineer and what do they do?
Machine learning engineers, they're developing models, computer science abstractions, which make predictions. So machine learning engineer is the person who collects data, analyzes data, train the model on top of that data to make predictions, then deploying model into production, then monitoring the performance, and etc.
Can you share any early life experiences that influenced you to make the decision to become a software engineer?
I remember in my childhood, I really enjoy geometry and algebra. So it started with that. Later on in life, I focused on engineering right after my university. So I think those two things really kind of brought me there.
You got your bachelor's degree in Moscow State University in applied mathematics. Could you tell more about that experience? Why did you pick applied mathematics?
I enjoyed mathematics when I was a child. I was not like super brilliant in that. But thinking where should I go after the high school, it was basically either mathematics or something like psychology. So my family, we decided that mathematics and applied mathematics, maybe physics, is kind of the direction I probably should go. The main reason for that is if you're going to study mathematics, you can switch later on in your life to any field or technical field you want. It can be physics, it can be computer science, whatever, because it's super fundamental thing for everything you do later.
Were there any particular projects or subjects of interest that you had while you did your bachelor's degree? I may assume that the mathematics there were pretty brutal. Did that go well for you?
Yes, honestly, it was a little bit too abstract for me. There's a difference between engineers and mathematicians. Mathematicians, they're thinking about problem in abstract and then go into the real life, kind of downsizing the problem. Engineers, they're doing completely different thing. They're starting with the small things and then building on top of that. So my brain is the engineer brain, not mathematician. So I had difficulty kind of building abstractions and then going to real life. But later in life, I had to learn how to do that, obviously.
After you got your bachelor's degree, why did you make the decision to go to Holt International Business School in Boston to pursue a master's degree in international business?
In my university, I studied mathematics and like applied math. It's not really a specialized thing. So I didn't really know where to apply my skills. And I figured I have 1 year or 2 years to kind of get really new experience related to business. So for that reason, I figured, what the hell, let's go to the United States and study there for a year.
How was that experience?
Amazing. It was super hard. So first of all, we are immigrants. It means that you need to learn language from like ground zero, even though you probably knew how to read books and, understand English movies, but how to communicate with people, how to build a smart conversation with someone, you really need to learn that. So I think this is the biggest thing I've learned how to do. The second thing is connections. We came to United States with 0 connections, right? You need to meet people, you need to build your network, and etc. And the 3, I started programming when I was at Holt. In the end of the program, I figured this is the best way to kind of to move forward.
So you started coding when you were how old?
21.
When you were studying applied mathematics in the Moscow State University, you must have had some programming courses there.
Frankly speaking, I hated programming. I didn't really understand the beauty of it. I remember telling my father, if anyone gonna pay me $1 million for the engineering job, I'm not gonna take it. So I didn't really see any beauty in programming and computer science.
What did you study there particularly that you hated so much? Was it Java?
It was C++ and super in mathematics, in differential equations. So it's really specific set of problems you need to write programs for.
Wait, you were writing programs to solve mathematical equations?
Correct.
And none of it no application to the real world.
Yeah, people would say this is the actual application in the real world, but I was on the same side as you. For me, it was not obvious how it's related to real life.
You started coding when you were in Halt International Business School.
Right.
How was that experience? How did you come up to that decision that I should start coding?
It was an interesting story. So I started working for the startup, and the founder, he asked me to focus on like CRM system or optimize the business development pipeline we had. I tried to solve it as a kind of person with a business degree, but I figured I can write a program to optimize communications with the end customers and business partners. This is the first time in my life when I figured, oh, you can write code to actually automate your process, and you are not required to do, I don't know, calls or cold emails every single day after that.
You dived into it. How did the journey go from that point? How did you evolve in that field?
The end goal was to connect with a bunch of potential business partners in the industry. That kind of was the problem I was trying to solve. You can solve it by calling people, by adding them on LinkedIn, and etc. I figured that it's much easier to automate that process by sending automatic emails, connecting with them on LinkedIn automatically through programs, and you can do it on completely different scale. So without programs, you would need to call, I don't know, 10 people per day. It's gonna take a bunch of time, a bunch of effort. But with the programs or software engineering, you can contact thousands of people in an hour, right? So it's completely different scale, and it has direct impact on the business.
And what language did you start programming?
I started with Python. SQLite was the database. I even programmed in VBScript a little bit.
So you have this problem that you need to solve. At that point, you didn't know Python. How did you get the initial knowledge?
It's a great question. I think your viewers don't really remember the time when you didn't have any courses on Coursera or YouTube videos. Just Googling. Thankfully, we had Google back then.
Stack Overflow.
Stack Overflow, just reading articles, reading documentation, things like that. Yeah. When I started programming, I quickly figured that it's impossible just to write code. Instead, what you need to do, you need to really understand how to test whatever is written. What I did, and once again, I didn't know how to write the code basically, right? I didn't know Python. What I did is I designed the pipeline where you have a problem. For example, prepare the email to send to someone. I wrote few scripts trying to build that email. But before sending that email to someone, I had a test suite checking if the mail is correct, if it's, look good, there's no errors. And basically I build the unit tests. Now we know how it's called, but then, just by thinking about the problem, I figured this is probably I should start with the unit tests. I wrote unit tests, and then I just started writing code, trying to make sure it's working. And step by step, I've learned new concepts. I remember there was a moment when someone told me to use nested functions. And I thought, what is, I know what a function is, but what is nested? And even Googling that, it's not obvious what does it mean unless you see it. If you see it, it's super easy to understand what is that. And I remember it was evenings after evenings, touching those new concepts and trying to figure out even what is that. Not even thinking if it's useful or not. It's just trying to understand what is object. Personally, for me, it was hard to figure out what is object-oriented programming. If you are reading the article, it doesn't make sense. Sometimes it does, but then in a year when you actually understand how it works, then you understand. I didn't have any clue what was that when I was reading the article. So once again, I'm not mathematician by the way my brain works. I'm an engineer. I need to see how it works and then kind of build abstractions on top of that instead of doing this vice versa.
Yeah, it's funny how mind and time play tricks on you. I remember when you try to learn the first steps, like hello world, what is a class, inheritance, and all those concepts. Over then, it seems like it is something scientific, gigantic, very hard to understand. But as soon as you do it like 10 or maybe 50 or 100 times, you look back and you think, oh, that's simple. I mean, I
Right.
cannot imagine that it took so much time to understand that. But I guess that's how programming works.
You see this huge mountain in front of you, you know you need to climb on top, but when you climbed on top, you're looking back and see that it was not a mountain at all, it was like a hill.
Yeah, and then you look forward and you see a bigger
Even
mountain.
bigger, yeah.
And it's nonstop.
Yes.
It never stops. So when you took up your first job, it was a startup, right? You implemented that algorithm. You did other work. How did you evolve from that job?
I slowly learned how to code. It took me, I think, a year. And then I was thinking how it's possible to stay longer in the United States to kind of gain more computer science experience or engineering experience. I sat down with a few of my friends in the computer science industry, and I tried to kind of bring everything together. I've learned mathematics, I've learned programming or coding, and I've learned business. I thought that I need to go to finance because it seems logical. You kind of know finance, as you may remember at Halt, we learned like corporate finances. I learned trading a little bit with like coding the trading bots and stuff like that. So I figured, okay, I need to go to trading or finance industry. I tried to interview with a bunch of companies, and it was like hitting the wall every single time. There are a few reasons behind that. One, I didn't have the actual professional experience in programming, right? It was not like a bunch of years writing low-level code or something like that. Two, I didn't have like a green card or some sort of that. I was on OPT, so in order to move forward, it was required for me to get a sponsorship.
A visa
Three,
sponsorship.
yeah. And three, English. I still kind of were learning how to speak properly. And it's especially hard when you are having the first calls with potential employer. You're trying to prove that you are smart and stuff like that, but your language just doesn't help you to do that. So I quickly figured, I think within few months, maybe 3 months, that it's not the right time to move to finance, even though I kind of wanted to. Before doing that, basically, I figured I need to get any permanent job in computer science for the next few years. And this is how I found my next company, New York Software. Low-level C++, computational geometry, where I could apply my mathematics skills and computer science skills.
Could you elaborate more on what we were doing there?
The business is quite fascinating. Imagine the oil field is the huge field full of oil or gas. There are companies who are like drilling holes to extract the oil. This is quite mathematical problem because in order to extract, in order to maximize amount of oil you want to extract, you kind of don't want to build too many holes because drilling the hole is quite expensive operation. So you need to model the oil field, and then there's a bunch of science, geology, mathematics, computational geometry, physics, trying to figure out where you need to drill holes or wells, the way it's called in the industry, to extract the oil. So our company was helping building grids to model the oil fields. Super specific problem to solve. At the same time, super interesting problem to work on.
So you're trying to predict the location of the oil?
No, our job was to build geometrical model to help people to make those predictions.
And after this, you transition to Acuna Capital. That's a company that specializes in market data and execution platforms.
Do you remember we discussed that I tried to get into finance, but I had to kind of stay in the computer science, pure computer science related to mathematics. In a few years, I think it was like 3 years after I started the New York software job, I knew it's the time to make that step finally. I knew C++ pretty well that time. I already started like building my experience in Python. And then I thought, okay, it's time to move to finance. It was my goal. Let's do that. So Acuna Capital is top company in trading and market making in Chicago. I was lucky enough to go through extremely sophisticated process of interviewing with companies, and I got the junior developer, I think it's called junior infrastructure software position.
And back then you only knew one language.
I knew C++ pretty well, and I knew Python.
Why C++?
C++, it's low-level language with enough abstractions on top of that. It's the way it's working, the way it's written, it's really good for parallel computing. It's really fast, efficient, and it's kind of high abstraction language enough to build good applications on top of that.
It is considered faster than Python.
Right. In fact, Python is written on C or C++. So.
Then you transition to EMX. That is a company for which you designed market data solutions and led various initiatives. Could you elaborate on that? How many years of experience did you have when you transitioned to the job at EMX?
It was 3 years of pure C++, then few years of Python / C++ experience at Acuna.
So at that point you become a developer, not just a junior developer.
Yes. The main thing was I was hired to build the market making platform from scratch on the platform. That was kind of interesting problem to work on.
Market making?
Market making is when you're trading on the trading market, you can buy and sell things. There's a specific...
On the stock market?
On the stock market. There you have specific set of companies who are focusing on buying, selling frequently, making some small profits, playing on volatility. And this is called market making. It's a little bit more sophisticated than that, but there's no point to go deeper. So I worked there, and it was, I think, more than 3 years I was in finance. The way finance work, especially the crypto part of finance, and it was 2017, 2018, it was the years where Bitcoin got popular and a bunch of things like Ethereum, etc. We were focusing on crypto trading. As you may know, there's 24/7 trading happening around the globe without any breaks. So trading job, being developer in stock exchanges or trading, it's really well-paid job. But at the same time, especially in crypto, you don't have time to relax. I remember I was going to sleep. My phone was always on. I was waking up at night because, I have some trading jobs or trading bots which were trading, and sometimes I set up the monitoring for myself to kind of review specific trades if they looked suspicious. So few times per night, I would always wake up to check if everything works fine, right? The same on the weekends. Every time I would go for a date or I would go for a hike, I was always having the laptop in my backpack. It's fun for a year or two, but at some point I figured, like, what the hell? It's not how I want to spend my life. And that time, I remember I took a break, slowed down a little bit, and maybe first time in my life I actually sit down and consciously try to figure out how I want to spend next 5 years of my life. It was not decision. It was not the short-term decision. Oh, I want to go there for the next year. I want to do this for the next year. It was like, okay, I have 5 years. How I want to spend those 5 years, the next 5 years. I sit down and once again, I kind of brought everything I have on the table, mathematics, computer science, business, and etc., etc., etc. I compiled everything and I figured maybe ML is interesting thing to work on. You need to know mathematics to be successful in machine learning. You need to know computer science, especially low-level languages like C++ and high-level languages like Python. Then you need to understand the business side of things. We're probably going to jump into this deeper later, but business side of things in ML is the most important actually among others. So I figured, okay, I can go as a senior developer to continue my trading life, or I can step back and start the path from ground zero and start working there somewhere as a junior software engineer. So,
as a junior software engineer in machine learning.
Correct. Yes. I took 3 months course about machine learning. I've learned kind of fundamentals of the whole pipeline, how to train the model, what are the main terms, concepts, how to deploy the model, why do we need models, how to monitor models performance and things like that. And I found few jobs. I got job proposals from various jobs, and I picked the best one I could. So I joined Delivery Club. Delivery Club is the food delivery service, one of the biggest companies in Europe. It was the biggest company in Russia for sure. Pretty incredible company. At that time, they were starting developing MLops platforms from scratch.
That was 2020.
Correct. MLops. So you're familiar with terms like machine learning or artificial intelligence. There's a whole subset of tasks required to make the whole thing successful. It's not only to train the model. You need to deploy the model somewhere. You need to monitor the performance of the model. You need to build the pipelines to train the models on the new data. You need to gather that data from either publicly available data sets or from your business, like in-house data, the way they call it. You need to transform it into the right format in order to train your model later on. There's a bunch of engineering set of problems around the actual ML model. So MLOps, it's machine learning operations. It's everything related to machine learning except the model itself.
Could you draft the main steps to deploy a successful machine learning model?
The main concept I think everyone should know is garbage in, garbage out, meaning data goes first. You need to gather or collect as accurate as possible data. Let's pick the example. Let's say we want to classify photos into 2 buckets, if it's a cat or dog. First, you need to gather or collect examples of those images. And then you need to accurately label them. This is the cat, this is dog, this is cat, this is dog. This is not a cat or the dog, right? So it should be enough data. For example, 10,000 images accurately labeled into the proper data set. This is step number 1 to make sure your data is clean. Then you need to split it into the training and testing sets. You're taking the training set and then you're using, most likely you're going to use existing libraries, XGBoost, PyTorch, TensorFlow, whatever you name it. Train the model, and then you're going to test your trained model against the testing data set. You need to figure out the metrics, how you're going to assess your model. There's a bunch of different metrics. The main thing there is to try to figure out how accurately you're predicting what you want to predict. So let's say you set up the metric, something like, square error, whatever. You take this metric and you're trying to optimize or minimize it. So you are taking the same training set, trying to pick different parameters for your model, train it once again, testing it, seeing the metrics. Is it better? Is it good? If it's good, we can deploy it. If it's not that good, let's try from the beginning. So there's a whole pipeline trying to figure out if your model is good enough to be deployed.
So you started out as a junior developer at Delivery Club, even though you had a lot of years of experience behind your back. How was that like?
I would not say it was hard. I was ready to make that step back and to be a junior developer. I knew that it's going to pay off. If you're working on something you're really interested in, it doesn't really matter. It's going to take a few years and then you're going to be there. This is exactly what happened. I started as a junior developer and then slowly I grew up to be a team lead, or in United States it's called engineering manager. So I was managing the team of MLops engineers.
How many years did that take you?
2 years. Took me 2 years.
And then you transitioned to TipTop.
When I was working in Delivery Club, I've learned how to build MLops, machine learning operation systems. I wanted to work on the same set of problems, but in the different field, and maybe at the startup to build the same thing from scratch. When I was developing those systems in Delivery Club, we were using only in-house solutions. That was kind of management decisions. So we were not working with any cloud providers like AWS, GCP, and Azure, whatever. We didn't use any things like MLflow and things like that. We can go deeper into that, but this is set of libraries or platform to train the model, to deploy the model, etc. We didn't use that. I wanted to get my hands on existing like frontier technologies. For that reason, I figured I need to find the best possible small company or startup in the United States where they need either ML engineer or ML infrastructure engineer or ML ops engineer.
Why not big tech, by the way?
When you are not in big tech, it feels like you're going to work on really huge problems, but most of the time you are sitting in the small project within the huge company and you are tuning existing solutions. It really depends. There are times when you're given new project to work on and it's incredible, super interesting, but most of the time you're going to take something which is already written by a few generations of engineers. You can actually see it in the code, like that was written 3 years ago with this kind of Python version. This was written a few years later and things like that. So And then you're just tuning the system. It's not that interesting.
Constantly running tests.
Constantly running tests are important regardless if it's a startup or a big company. This is what I learned in finance. It's really easy to jump into details in some technical problems, but it's super important to keep thinking about the business. So in startup, your daily activities are really attached with the business needs, and your work directly impacts the business. In the big tech, probably you can work 2 hours per day for the next 2 years, and business not gonna even be impacted by that.
The distance from you to the impact of your actions is very big in big tech.
Correct.
That can be daunting. But a lot of people still strive for working at Amazon and Google.
100% understand why. First of all, imagine you're going to university, you're spending 4 years there studying computer science. Then probably you're gonna go to take a master's degree in computer science, right? So especially in the United States, your family should pay like huge amount of money to get you there. You have some credits already or debt. You want to find a job with a good salary, with a good like health insurance and things like that, and just to make sure you're gonna have a normal life for the next 5, 7, 10 years. I understand why people are choosing to go into big tech, 100%, but it's not for me. I was always ready to take risks, and I was always wanted to work closer to the business. Maybe it's related to why we were doing at HALT, International Business School. Maybe something comes from my childhood or something like that. I have no idea. But the main thing is I want to be closer to business. I don't want to jump too deep into technical details which are not affecting business.
What would you say is the biggest advantage of working in a startup?
Being able to consistently improving the system no matter what, regardless to circumstances you're working on. In the startup, this week, everything is fine. You have enough capital, enough users, enough traction, everything is fine. The next week, something changed. Everything is breaking down into pieces, and regardless to what is happening, you need to keep working on your part of the business, on your problem. Sometimes you need to kill the problem you're working on because it doesn't really necessary for the business to move forward. So it's ability to work under the absence of any predictability.
So what is it that you exactly do at TipTop?
Our company focuses on e-commerce and logistics. We're helping people to sell their used devices. So for example, if you have used iPhone, you can use our app to get kind of the buyback amount we're willing to pay for your used iPhone. You click the button sell it, then courier comes within 5 minutes, takes your phone, and then you have money on your bank account.
Instantly, without even looking.
There's some science and business decisions behind that. In most of the times, no, we don't need that. In some cases, we do. But the idea kind of looks simple, right? You have your used phone. You need to know the price. We need to pay you this price, and that's it. The deal is done. Behind the curtain, there's a bunch of data science problems or machine learning problems. First of all, you need to make sure your pricing predictions are correct, right? You don't want to overprice. There's a balance between, obviously, you want to have the higher price for this iPhone. In order for us to be profitable, we want to lower this price. So there's a balance, supply-demand kind of balance thing, or pricing elasticity. So you need to catch that with your pricing solution. Then there's a bunch of problems related to machine learning how to organize logistics. We have a functionality when you can connect your Gmail account and we're going to find your receipts. And there's a variety of ML related problems, how to classify receipts, how to extract meaningful data out of that, how to find those products in our internal catalog and things like that.
What is the difference between a regular machine learning or a software engineer and a founding engineer?
The main difference is you are super accountable for the business outcome of what you're doing. I can recall, 100 different cases where I had to write the actual backend code, not ML related code, because it was necessary at that time. You need to sometimes jump between technologies, not only related to your core responsibilities, but jump to something which has the biggest impact to the business. I think this is the biggest difference. You need to always think about the impact on the business.
So you're a founding engineer. You have a lot of responsibilities. You have a lot of things you need to do and overlook at the same time. Can you describe your typical day?
My typical day starts with the following. First few hours of every single day I'm spending on monitoring our existing solutions we have out there. So we've set up monitoring or tracking things to make sure that our system is not degrading. And this is basically what you are doing on a daily basis, is trying to avoid this degrading thing. So 2 hours per day, I'm just checking if the data, our predictions are accurate, if everything works as expected. If not, then I'm creating kind of tickets to work on. I'm trying to understand if there are any bugs and things like that. So the first hours is the monitoring, trying to understand or trying to check if the system performs well. Later, we have few hours of focused work. It's either trying to improve existing solutions or trying to look at the business and thinking how you can be helpful for the business. Maybe new projects, or take existing projects and implement some machine learning solutions there. Most of the time it's optimizing the existing solutions, making things faster, making your models smarter, fixing bugs, and etc. Later, we have our daily kind of check-in or stand-up, when everyone is on the team is kind of talks through things he's working on. We are not the huge team. We're like 15 people. We have this ability to kind of understand who is working on what and make sure that we're not working on something meaningless. Sometimes I think that things I'm working on is super important for the business, but they're not. I need this feedback from the team saying, hey, Pasha, I think this can wait. Let's focus on this, right? So it's always the discussion. And later during the day, it's once again some technical stuff or designing new projects, discussing how your system or how things you're working on actually works with other parts of the system. It's already kind of complex thing, right? Bunch of communications, a lot of many lines of code.
They say the more you grow, the more meetings you attend and the less code you write.
No, it's not true. And we're fighting with that. It's kind of the company's policy, and what we're trying to solve every single day is avoiding meaningless conversations. In terms of amount of code, sometimes one line of code written is better than 1,000 of lines of code written. It's hard for me to kind of figure out if number of lines is higher than before, but I still writing the code a lot, especially as you may know, ML machine learning models is the code itself. So you have the code for the existing model, you have a code to interact with this model, You have a code to train this model. You have a code to collect information or data to train this model. There's a bunch of different places where you need to write the better code.
Yeah, it is a
bugs.
dance.
Yeah, this is the crazy dance. Yes.
How do you manage your time and prioritize tasks?
One way is I have a much better understanding about machine learning part of things in our company because I'm working on that on a daily basis. I really understand where we have some missing parts, where the system needs to be improved. The second thing is we have a team and we have like number of people who are super experienced. They know the business side of things and they know how to build scalable systems. So on the one side, I have my understanding what I need to work on, but it should be aligned with what other engineers think I need to focus on, or kind of our data science team need to focus on. So once every week on Mondays, we're sitting up with team and we're trying to figure out what do we want to accomplish this week. And we're just discussing, just speaking, hey, I have this idea. I think it has the biggest impact on the business. Let's work on that. So once again, it's just communication.
Can you walk us through a process of designing and executing a project?
First, you need to think about the business side of things, what you are trying to either minimize or maximize. For example, if your company helps users to identify if there's a cat or dog on the photo, maybe you are trying to be more precise about your predictions, right? Maybe you want to build a better system to process those things faster. Maybe you want to build a better UI to upload those photos. There's a bunch of different things. So the first thing I would think about is the business impact. Do you want to minimize number of, fraudulent users? Do you want to minimize number of errors in the system? Or you want to maximize number of paid customers? Or you want to maximize the revenue? Things like that.
Is there any particular challenging projects you could relate to in your work experience as a machine learning engineer?
If you're going to start working in ML industry, there's a classical set of problems every ML engineer gonna go through. The classical problems are classification. In different companies, it can be a little bit different problems, but in general, you need to classify set of things into some subset of, labels. Sometimes, for example, you want to classify tweets if it's a friendly tweet or
to determine the context.
Yes.
Yeah.
In some cases, you want to say if this is cat or dog. It's those problems are all kind of classification problems. Another classical problem is the matching problem. You want to match one identity to another identity and say if it's the same thing or not. In our company specifically, I was working on matching model in order to match things we see in the receipts or out there on publicly available data and compare it with items in our internal catalog. Do we have that Dyson air purifier in our catalog or not? So this is the classical matching model. The business impact is clear. The better we are with matching, the better kind of buybacks we can create, the better users we can have with that, the better pricing predictions we can have. There's a bunch of things there. The problem is there's always limitation. You're always going to be constrained with either time, resources, or technology, or something like that. You need to find the balance. Do you want to have super good precision, super good recall? Model should be super fast, or it's not that important, and things like that. So you need to find the right balance between different things. And that was the challenging thing to do. You can create super accurate matching algorithm, but it's gonna work really slow. So for the business, it's not gonna work if for the single prediction you would need 20 seconds, right? You can lower the quality of your predictions a little bit to make the system work faster, for example. And it's always, there's no right or wrong. It's always like honest communication, conversation. Where do we want to go?
It's the constant fight, fine-tuning your loss function.
Correct.
Adjusting the model to make better predictions.
It's like GPT or any LLM. In some cases, you want to have faster predictions, right? In some cases, you want to be super accurate and you can wait a couple of seconds more. In some cases, you need to be super good in specific fields. In some cases, you can be okay with generalized knowledge, right? So there's always balance.
Let's talk more about what is exactly software engineering.
When I think about software engineering, I think about scalability and automation first. It's not really about writing the code. It's more about building scalable automated systems. It can be done by a huge number of lines of code. It can be done by one line of code, right? It doesn't really matter. The main thing software engineers do, they're writing code or programs to automate things. And I think this is kind of the main thing we do. And if you can build a scalable solution, it's even better.
When you initially opened my eyes to computer science and Python programming, the first thing you said is programming is about problem solving. And that kind of cracked my mind because I could not understand how does a syntax could be related to solve some problems, because at the end of the day, this is just a language. Could you elaborate more on the traits and skills that people need to have before they make the decision to become a software engineer?
There are two kinds of people. One is super technical people who don't really care about the business, and it's totally fine. And if they do have good engineering managers, they can focus on engineering solely. And for them, you just need to learn technologies. You need to know how to solve technical problems and understand the system design, how to design the system to make it scalable. There are other kind of people, and I'm one of them, with kind of better understanding what the business needs and things like that. There you need to know a little bit more about how to communicate things, how to organize projects you are working on, how to prioritize things which are needed to be done, as well as technical skills.
The main assumption that I've heard is that to do software engineering, to code, you need to know math, and you need to know well. That is the thought and the perspective that has been imbued in my brain since I was a child, that you have to be born with a calculator in your hand in order to do this. That's why it was quite astonishing for me to discover this world that is actually more accessible than it is perceived to be, at least for me. Would you say that a strong foundation in math is essential for people to start programming?
I think engineers are the worst mathematicians. The misconception comes from the following. Mathematics is not the classical science, it's the instrument to do things, right? Physics is the science. Mathematics is just your tool to bring some sense into the problems or write them down on the paper. In this sense, computer science is mathematics. It's not kind of science on its own. It's your tool or instrument to make things done. So in this case, it's not like you need to learn mathematics or you need to know mathematics. It's more like you should be able to learn new tools like mathematics or like computer engineering or whatever.
So to elaborate on that, it is technically possible to write code without knowing math because it's been highly advertised on the internet. You can go through a boot camp, you can go through coding courses, and they never touch discrete math or any calculus, and that's fine. And they advertise it in a way that it is okay not to know math. What do you think of that?
I think it's totally okay to not knowing math. What you really need to know is arithmetics. Basically, when you're running your code, there's some execution time. You need to figure out if this part of code takes, 80% of the full execution time and things like that. But this is arithmetics. It's not even mathematics. But if you want to work on machine learning, it's really important to understand mathematics. Because mathematics, I would say the following. As I mentioned before, coding or computer science is the tool and mathematics is the tool. In machine learning, the main tool is mathematics. Behind the curtain, everything what is happening is actually like matrix multiplication, some algebra, probabilities and things like that. Statistics, yes. Further we go in terms of the building a better tools or better libraries, it seems like you don't really know to learn, you don't really need to learn mathematics. I don't know what's gonna happen in like 5 years, but today, even if you're not gonna see kind of mathematics on your own when you're running some library or you're using some library to solve the problem, you need to understand what is happening under the hood, because in order to optimize hyperparameters, in order to set up the proper metrics, in order to move forward in the direction of a better model, you need to understand how it works.
That's what I found fascinating because I saw these models. I was very curious how these things work. And only after you go through this hell of pain of studying that high level statistics, math, and probability, you understand when you actually get to see the beauty inside of it. Because when it makes sense for you how Bellman equations work, Markov chains, gradient descent, whatever, you see that it is a form of an art with the use of math. It is very cold, it is very accurate, but it's beautiful at the same time. With the right set of tools and the right setting, you can achieve pretty much amazing things just basically using statistics and math. This is decision making by math.
100%. I remember when I was studying at Moscow State University, I didn't really like mathematics. I didn't really understand why it's needed, how it works. Obviously, you can spend hours trying to understand how to prove this theorem and etc. But the moment I fall in love in mathematics, it was when I was taking my first course in ML, in machine learning, because I saw what is happening. This is the abstract concept. You're applying this to this problem, and then you have the result, which actually makes sense, which is fascinating.
That is actually my main takeaway from MIT that I can take, is that you can make decisions mathematically without even stressing your brain, just using the right equations with the right concepts and formulas, and you're all set. Are there any specific areas within this field that you are particularly passionate about?
Operations, I would say. The way I think about operations is to make sure that things on your table are in the right order. I don't know what kind of table you have at your house, but on my table, everything should be structured for some reason. I really find this really exciting to organize things. So operations is to design the system where every single step is thought through, makes sense, organized in the right place for the specific value, let's say. So in ML, as we discussed before, you need to collect data, you need to train the model, you need to deploy model into the cloud, you need to monitor this model, you need to see how the system communicates with that. And this is operations. And it should be really well designed and structured, because at scale, when you have 100 different models, you don't have time to kind of remember what is done here, what is done there. It's, as I mentioned, automation and scalability. They're kind of really important concepts. In machine learning, it's the same thing. If you have 100 models or 10,000 models, the system should be scalable and automated as much as possible and organized to move forward.
Is having a degree in computer science is mandatory to become a software engineer?
It's not mandatory for sure. It can be helpful. The main thing here is you don't know where we are going. You can take the computer science degree at the university, and they're gonna teach you how to, how computers work, how operating system work, and it's good. But imagine the world when, artificial intelligence or this kind of AGI thing takes control, and it might be a different world. Maybe operation system is going to be designed based on LLMs and things like that. So it is 100% helpful. It's going to get you there, but the main thing is ability to learn and adapt. In this case, it doesn't really matter if you took you took degree in mathematics or physics or in computer science. Maybe for the first few years, it's going to be easier for you to get a job if you have computer science degree. But over the longer period of time, it doesn't really matter. But the technical degree is definitely helpful.
There are a lot of courses now online, YouTube channels, boot camps. What do you think is the most effective alternative way to a degree?
It's a really hard question. I've learned programming by coding. I didn't go to any boot camp. I didn't take any courses and things like that. I learned it on my own just by making mistakes, writing inefficient programs, crashing everything and things like that. I've learned it this way, so for me, it seems like the most natural way to learn things, just break things. Just learn by doing. There's a plenty of platforms when you can do something even for free for someone.
One of the first things you told me when you opened up the Pandora box of Python programming, the Python language, is you have to know how to Google. And you specifically mentioned that Googling is an essential skill for any software engineer. Can you elaborate on that?
I would reframe this. I would say it's crucial to ask the right questions, especially with the systems we have today, like Perplexity or OpenAI or Mixtral. There's a bunch of systems. You need to ask the right questions, then you're gonna get the right answer. This is, in terms of Googling, it's kind of the same thing. You need to frame your question properly to get the best result.
It is a skill.
It is a skill, and by saying skill, it means that you're gonna do things in the wrong way in the beginning, and you're gonna learn how to do it in the right way. It's not a problem.
What are the general possible pathways inside the software engineering field?
I would start with thinking about the problems you like to solve, and then go into technologies behind that. For example, if you're interested in building the systems to make it more convenient for people to buy things online, right? Or make the full process of buying things as flawless as possible, then probably front end might be interesting thing to work on. If you are interested in building the systems where the knowledge is extracted from the underlying text and different sources, maybe machine learning and specifically NLP problems are interesting. I would start thinking about the problems you are trying to solve. And usually we do know what kind of problems we're interested in.
So generally, to conclude, you would say that there are two pathways of going back end, front end, or a point of start, the initial decision from which you take the direction.
I would say there are more than that. There's front end, there's back end, there's mobile development, there's QA, quality assurance, there's DevOps, developer operations, and there's data science.
What is the difference between machine learning and data science?
I think data science is just umbrella term, is the field focusing on data, extracting knowledge and key insights from that. And machine learning is the subset of data science where you're using the data to make predictions.
To conclude, in machine learning, you're building algorithms that are going to do something with that data, build predictions, generate outcomes. Whereas as a data scientist, you more like analyze the data.
Absolutely correct. In data science, for example, the data science project might be how many users came from that source to our platform, or how many users bought apples last week, right? It's just analyzing data and trying to get some insights from that. If we're speaking about making predictions about your revenue or making predictions where the user would go on your page, it may be a sign that it's machine learning.
What specific programming languages do you prefer?
I think there's no right language, but there's probably a better language for a specific problem. For example, if you need to write scripts to automate some business process, maybe it's Python. It may be not the fastest language, but in terms of syntax and functionalities, you're gonna get there. If you are building the web apps and you need good backend server-side language, it might be Rust, it might be Golang. There's a number of them. They're faster. They don't have that much maybe functionality as Python, but it doesn't really matter because the set of problems you're working with is different. If you're writing the trading programs when the speed matters, then it's C++, right? Python is too slow for that. So for machine learning, I would say Python is kind of the requirement. C++ is good to know if you want to go a little bit deeper. And the third thing, I would learn some language which is used to communicate with your machine learning models. So from my experience, when I'm building classification models or matching models or parsing models, we're using Golang code to send predictions, get this prediction, process this prediction, show something to the user, things like that. It's really helpful to really understand how it works, and just because personally I'm writing Golang code on a daily basis to communicate with my models. So,
even though C has higher performance rating than Python and Go, you still use Go. Why not C?
Go was specifically designed for those kind of problems, web communication.
So if you are starting out and you need to make a decision to pick your language, what would your advice be to make that decision?
I would say the following. At first, it might be easier to pick up the high-level language like Python and start. So the barrier of entry for Python is much smaller. You can start from that. There's no problems with that. But more experienced you are, you need to learn more sophisticated concepts, and it's easier to learn them with like C++ and stuff. For example, it's quite hard to explain what the pointer is if you didn't work with that. In C++, this is like super core idea. Once you play with that, you really understand what is it. If you only programmed in Python, you have no idea what is that. So
I remember we had Java courses on my computer science journey. I hated every single moment of Java. I don't know why. I'm just more of any other language, but rather not Java. I don't know how to make a distinction. I would guess that you would just have to check every one, I would assume, if the syntax seems offending to you in some way. For example, I know some people love curly brackets and they just can't live without them. It seems like something is in order. And I'm on the other side. I prefer more Python type of syntax.
I would say the following. Start with the problem. What problem you're trying to solve. Depending on that, you can pick the language designed for this specific set of problems.
Would you suggest that a person should try and take the basic problem, like writing a calculator program, and write it in different languages and see how painful each one was, and make the decision on how appealing the syntax is to a person?
Yeah, I would encourage people to make mistakes. Try to learn Python. If it's not something you like, pick the different language. Just keep trying.
Any IDEs that you prefer?
Personally, at some point, so there's Vim. It's kind of special, hardcore, old school IDE thing. It's not even IDE. It's super low level way to edit the files. I'm a fan of that. For most of the people, it's a little bit crazy. So I was always doing that. At some point, I switched to PyCharm and Golang, but I'm using the Vim plugin just because it's faster for me.
And what about VS Code?
I tried it, really good. I really like PyCharm and Golang, but VS Code is really nice as well.
Do you use Copilot?
I do. Yes, I started using it like 6 months ago.
Do you think people who are starting out should be using Copilot?
No, but they will, so there's no way to stop them. It's fine. You can use it. Just don't use it without putting a second thought into it. Sometimes they're writing bad programs.
How do you stay up to date with the latest tech and coding trends?
3 things. Twitter. What I'm doing is the following. When I'm starting something new, at the same moment I'm starting following the main influencers in that area, right? So I'm really on top of what is happening. The second thing, I'm picking the email newsletters I'm interested in. For example, for ML, I have number of subscriptions I have. So every morning I'm sit down and spending like 5 minutes kind of reading what is happening. And 3, if you jump into some field, just speak with people. They're going to tell you what they use, and yeah.
If someone would be starting out today, if someone would make a decision to become a software engineer eventually, would you say that understanding signal transmissions and other hardware aspects that are being fed to us in universities is important for software engineering?
There are a specific subset of problems where it's super crucial to know those things, especially in top trading companies. There are projects specifically related to hardware optimization, where you are placing your code as close as possible to like CPU and using like cache and things like that. This is where it's required. But in 95% of times, 99% of times, it's not required. Personally, for me, I need to understand the difference between like CPU and GPU and TPU when I'm training my models. But it's kind of high level understanding. Yeah.
If you would be starting out anew today, what would be the first steps that you would take to understand how to code?
Pick the simple program. For example, you mentioned calculator. We can do that. We can try to build the web app. We can try pick some machine learning problem. For example, classify flowers into some categories. Just pick the problem and start like building that.
What are the foundational concepts that, in your opinion, every software engineer should know?
You need to understand the difference between front and back end. Let's start with the like high level things, and then we can go a little bit deeper. You need to have a little bit understanding about how systems operate. Like what is the data?
The operating systems?
No, systems like engineering systems, infrastructure. What is the database, right? Why people are using databases? What is the front end, back end? How to send requests from one service to another, REST API, and things like that. In terms of languages, obviously you need to learn what the function is, what the variable is. This is like super classical thing, but at some point you need to figure out how to work with classes, especially if you're working with Python. In Python, as you may know, every single thing is object. You really need to understand what the object-oriented programming is.
What about version control and GitHub? Excuse me.
Yes. At some point, it would be really nice to understand how it works. The moment you need to learn how to do this is when you're working on the project with someone.
What about leak code? Overrated, underrated?
I think it's underrated in terms of people think that lead code is only required to get a job. But actually, it's a nice place to train your brain on solving small problems. It's like puzzles.
A gym for your brain.
It's a gym. It's like a morning jogging for your brain, I would say.
I remember that my ears were and my eyes were bleeding after I saw the first easy task there. That completely tripped my mind, and it took me many, I would be hesitant to say, months even to get an understanding of how to actually solve these problems. It's not about memorizing the code, it's about understanding the mechanics behind making a particular solution, because there's like 10, maybe dozens of ways how you can solve the same task. But what is also important is understanding the concept of complexity.
Complexity is important. You are completely right about that. Every problem has like bunch of different solutions, number of solutions. Not all of them are good enough or not optimal, the better way to say it. So yeah, complexity is something to consider. Before, people would think about memory consumption as well, but it's not that required these days because we don't have problems with memory.
Initially, it did not make sense for me. How does understanding how to write a two-sum problem or merge lists containers or rearrange an array, whatever, how is that related to an actual job?
Most of the people would say it's not related at all, but It does. Those concepts like linked lists, binary trees, stacks, queues, and things like that, they're in core of most of the problems. So you really need to understand them. Probably you should not be like expert in lead code to solve like expert level or hard level of problems, but you need to understand those concepts for sure.
Working as a software engineer often, and especially after COVID, is working remotely. How does that impact your life?
You have a better control on your day-to-day activities. It comes with price. Personally, I found myself working better at WeWork. I'm productive at home, but at WeWork, I'm just coming there at 9 and there's nothing else I can do other than work till like 7 p.m. And just sitting there and working. So working remotely is great. For some people, they're losing their productivity. For me, it's not the case, gladly.
There are many subdivisions. There are many specializations in the field of AI and machine learning. It could be computer vision, natural language processing, deep learning, and so on. What would your advice be for a person who's thinking of transitioning into the field, into a particular one? First of all, how does he make a decision which one to choose? And second of all, when is the point when you're ready to make that transition?
I think I would not say it's harder to switch to machine learning from engineering than from any other field, but it's extremely hard. And the problem for that is it seems logical that software engineering is kind of close to ML, machine learning, but in fact it's not. It's completely different problems, require completely different skill set. I would say the following. You need to learn math. This is the biggest difference. So in software engineering, math is not required at all, but this is everything in machine learning, right? Before thinking about transition, you need to learn probabilistic theory, statistics, and like classical mathematics, like algebra, matrices, calculus, things like that. This is the first thing. If you're a software engineer who thinks that he wants to switch to machine learning, I would recommend to do what I did, is to go first to MLops, ML Infra, which is right in the middle between ML and software engineering. There you can still write code to train model, to deploy models, things like that. But at the same time, you're slowly gonna start learning the main concepts, right? What is the ROC curve? What is the precision and recall and true, false, false, negative, whatever. And then slowly you can make that transition. The important thing I forgot to mention, if you want to do the hardcore, but probably is the right way to do, go to Kaggle. This is the platform specifically for like Kaggle or Kaggle. It's where there's a competitions between like ML engineers who can train their model, who can build a better model. There's a bunch of different resources, data sets, articles, bunch of different stuff. You can start compete. You can start with super simple problems, and then step by step, you can become really good ML engineer.
There's a really careful approach about entering the field of machine learning, as far as I know, that there are two ways how you can do this. You can start off working straight away and playing with frameworks like PyTorch, TensorFlow, Keras, whatever. And the other way is to manually build your own neural network with using the math and everything behind it, building the hood, and only then transitioning to the frameworks, what would your advice be if someone would be starting out now?
If you're working in the business, like if you have a job as an
If
ML
you
engineer,
are already a software engineer and you think of transitioning into machine learning, would you advise on first playing with TensorFlow and PyTorch, or would you advise on building your own neural network?
it's always better. I think for every engineer, it's better to build your own thing to really understand how it works. I would encourage to build your own neural network. But if you want to do the transition, you need to know how to work with, for example, if the PyTorch is used in the company, you need to know that, or XGBoost or CatBoost. There's plenty of them.
How do you describe your approach in interviewing candidates?
There are three things I'm interested in. First is just the general communication. We're dealing with sophisticated problems. Sometimes there's no right solution, right? I need to understand how the candidate can decompose the sophisticated solution, sophisticated problem into kind of something simpler or into hypothesis to test, things like that. From the technical standpoint, I'm checking, so if it's related to ML engineering, I'm checking a few things: Python or coding, and ML related like concepts and understanding, core concepts in statistics, things like that.
And how do you assess these technical skills?
By giving the problems. For example, I can give a problem, something like design me a class, the Python class to do X, right?
And what about whiteboard coding? Do you believe that's necessary?
It's really helpful to check system design. So if you want to test, if you are interviewing MLOps engineer, the system design questions are super important. By system design, I mean we're taking the business problem. Let's design the music recommendation algorithm, right? And then we need to design the system, how it's going to work, how we're going to scale this thing. Do we have BigQuery or Postgres databases? So how we make a decision if we want to pick relationship database or tabular, whatever. How we make sure that our ML part is scalable, how we're going to train the data, how we're going to collect the data. So for those things, the whiteboard is super important, so super helpful. You can erase, you can, play with that. So, yeah.
But what about writing code on the whiteboard like they do in big tech
Pseudocode
companies?
is fine, but these days you can go and writing actual code on your notebook and just run it right in the browser.
How do you evaluate a portfolio of a candidate?
Personally, I'm trying to see if the candidate, I'm not speaking about super junior people, right? So we're not hiring super junior people out of college or something. I'm trying to see if the person solved difficult problems, difficult business problems. Two, I'm trying to see if he was growing in the company. It's a good indicator as well. And I'm trying to see the balance between technical skills in his resume and non-technical skills in the resume, because people sometimes tend to hide technical skills just because they think it's not that important, and it's maybe an indicator that person didn't really work on those things. On the other hand, there are people who are putting too much technical skills on the resume. Oh, I worked with VBScript, C#, and R. And personally, I don't really care what technologies are, because you can learn them. I'm looking for a little bit different things. So there's a balance between technical and non-technical details you need to add to your resume.
Does that push you away when you see a candidate that has 5 programming languages?
I mean, usually if you learn more than 2 languages, like 3, it doesn't really matter if you know 5 or 10. The second language is first language is the hardest. Second language is kind of hard as well because it's a completely new thing. But after that, it doesn't really matter.
And what about a GitHub profile? Do you look at personal projects that have been made before hiring someone?
Yes. It's not the requirement. But if I see the link, I always go there and see what hobbies may be there, or what person was working on. Sometimes you can see that the GitHub was created just to show something, which is fine if you're a junior developer. But if you're a senior developer, like, what's the point?
What if you see a project like a to-do list project in a portfolio of a candidate? Is that a red flag for you?
No, if it's a junior developer, it's really good. It's actually really good. If it's middle or senior developer, I don't see there's a point for that.
About a year ago, ChatGPT was released to the public. Are you using this tool for your daily work?
I'm using this for my day-to-day activities. I'm using some functionality at my work for the business processes. And I'm using on a daily basis, asking questions, helping me out with ML related stuff. So I'm using actually not only GPT, but Perplexity AI as well.
Could you point out the difference between them?
There's not that many difference, especially with GPT-4, but Perplexity AI, they were the first company who figured that you not only need the text or explanation, you need sources. So Perplexity AI kind of gives you the answer and then the sources you can later use for your research.
Do you think large language models will influence the future of junior developers? If someone is thinking of starting a career as a software engineer and you have these large language models that can technically replace 10 junior developers, meaning by functionality because they can write easily low-grade code, you just need a person who can supervise it and implement it.
You need to train developers to be good developers, even though LLMs probably can write some code. There's a need in junior developers to train them to be a better developers, for sure.
Do you think that English is the hottest programming language, also called as prompt engineering?
Yes. As we discussed before as well, you need to ask right questions. In order to ask right questions, you need to properly speak English. That's for sure.
That was one of the most hard things for me to take as a person from not computer science field. The truth that you opened my eyes to is that if you wrote a program and it doesn't work or gives the wrong input, the probability is 99.9% that you did a bad job, which was kind of eye-opening and very influential at me back then. It changed the way how I think and perceive things. But that's how I think all software engineering and prompt engineering works. Especially I see that when people try to use large language models and they fail and they just quit because they just got a bad result. But the actual truth is that they A, don't know how to use the model, and B, they don't know how to ask the question.
Yes, and they don't know how to assess the performance.
How can one best start their path to become someone like you? Where would you start if you were starting anew?
It depends where your starting point is. If you are not in software engineering and you are doing either the business degree or somewhere not in software, not in the coding, don't be afraid to start from the ground zero. It's gonna take 1 year or 2 years, but you're gonna get there. This is the first thing. The second thing, don't be afraid of making mistakes. If you didn't do any mistakes, you probably didn't do anything. Try to submit resumes to a bunch of different companies. You're gonna fail. people not going to even answer to you, right? Then you're going to iterate over that. You're going to figure out, oh, I need to add those skills, or I need to add this project. You're going to send another bulk of emails, and 10% of people going to say, not interested in this time. And then you're going to sit down and thinking, okay, what next iteration I can do to get, further. It's kind of ML process as well. You are designing the test, you're running the test, getting the response from the industry, from the outside world, adjusting your input and running another. So keep trying. Maybe it's not the best advice. Just make mistakes. Keep trying.
Did you have burnouts and imposter syndrome during your journey as a software engineer?
This year I had 2 burnouts. Only this year.
And how does that happen?
It happens. There's a scientific underlying reasons why burnouts are happening. I'm not gonna go into much details there, but basically it's a lot of work without the output. When you losing this connection between doing things and seeing the output, it completely breaks your brain.
Like you're disconnected from your job, from the job output.
When your daily activities, they're not reflected in the output, right? You did something.
They're not fruitful.
Something like that, yes. So burnouts, they're really easy to not be seen and really hard to solve. The first time I got burnout, it was 2018 during my trading work. And that time I was smart enough to just call the psychologist and start working with him. And he learned me a lot. I would not be able to go this road without the psychologist. So burnouts are possible. It sucks. Don't do this. But if it happened to be, speak with professional, that's for sure. Yeah.
And what about encountering imposter syndrome? Did you have that?
Yes. Every software engineer or ML engineer, I think you constantly understanding that you don't know enough. Some people can live with that, kind of understanding this part of our nature. We don't know anything. Especially when you're a junior developer, at some point you're going to get this idea, oh, now I know everything. I know how Python works and how to send a request to database. But further you go, at some point you will understand that you have no idea what's going on around. And it's either you're going to live with that or you know.
It's like a loop. The more you know, the less you know.
Exactly the case.
Looking back, is there something you wish you had known before you started out as a software engineer?
One thing definitely is courses is really good. The thing is, these days, everyone is taking the course before doing anything, but before you could you had a choice trying to learn on your own, or go to take a course. For example, with running, it took me years to figure out how to run properly. It probably would took me a few months with the expert, with a teacher, with a mentor to learn how to do it. So I don't know, some people like doing things on their own. Some people like to speak with the mentors. I would encourage people to ask for help and speak with the smarter people.
Pavel, I would like to say thank you. You are an amazing person and a dear friend. Thank you for changing my life and everything that you have done for me, for believing in me that I can become a software engineer and that I can actually write code. That was a big leap of faith that you put in me. Thank you for that. You've changed my life forever, and I'll be forever grateful for that. It was an honor speaking to you today.
Thanks a lot.